This video continues our discussion on welding, focusing on solid-state welding and weld quality, including defects, inspection, and testing methods. The content covers solid-state welding, specifically friction welding, and weld quality, focusing on defects and methods for inspection and testing. Welding can be broadly categorized into fusion welding, which includes arc, resistance, and oxy-fuel gas welding, and solid-state welding, which includes friction welding. Solid-state welding achieves coalescence through pressure alone or heat and pressure without filler metal or melting of base metals. Surfaces must be very clean and brought into close physical contact for atomic bonding. Friction welding, or FRW, uses frictional heat combined with pressure, typically by rotating one part against another, raising the joint interface temperature. It requires no filler metal or shielding gas and is used for mass production, especially for shafts and tubular parts, and can join dissimilar metals. This diagram illustrates the 4 steps of friction welding: rotating one part with no contact, bringing parts into contact to generate friction heat, stopping rotation while applying axial pressure, and finally, the completed weld. Weld quality is affected by residual stresses and distortion. Rapid heating and cooling generate residual stresses, leading to distortion and warping in the welded assembly, such as shrinkage and warping shown in the diagrams. To minimize warping, techniques include using a welding fixture, heat sinks, tack welding, selecting proper welding conditions, preheating, stress relief, and proper design of the weldment. Cracks are among the most serious welding defects, causing fracture-type interruptions and significantly reducing strength. They are caused by embrittlement or low ductility, combined with high restraint during contraction. Welding defects include cavities, such as porosity, which are small voids from entrapped gases or contaminants. Shrinkage voids are cavities formed during solidification. Solid inclusions are non-metallic materials entrapped in the weld metal, with slag inclusion being the most common form. Incomplete fusion, also known as lack of fusion, means fusion has not occurred throughout the cross-section. Lack of penetration is another type where fusion has not penetrated deeply enough, as shown in the diagrams. Imperfect shape or unacceptable contour includes defects like undercut, where base metal is melted away, underfill, a depression in the weld, and overlap, where weld metal spills but no fusion occurs. Inspection and testing methods are essential for judging weld quality and integrity. Visual inspection is the most widely used, checking conformance to dimensional specifications, warping, and surface defects like cracks and cavities. A key limitation is that internal defects cannot be detected. Before welding, inspect materials, standards, qualifications, equipment, edge preparations, and fit-up. During welding, monitor preheat and interpass temperatures, cleaning, and structural defects. After welding, inspection includes dimensional accuracy, conformity to drawings, appearance, and the presence of defects like unfilled craters or cracks. Proper weld joint preparation, including cleaning the base metals and ground clamp attachment area, is crucial for good weld quality. Non-destructive evaluation methods do not damage the specimen. These include dye-penetrant and fluorescent-penetrant tests for small surface defects, and magnetic particle testing for subsurface defects in ferromagnetic materials. Other non-destructive evaluation methods include ultrasonic testing, which uses high-frequency sound waves to detect discontinuities, and radiographic testing, which utilizes X-ray or gamma radiation to find internal defects. Destructive testing methods destroy the weld and are divided into mechanical tests, such as tension shear and fillet break tests, and metallurgical tests, which examine the metallic structure and heat-affected zone.